Hi. Now, in this example then, we've got the continuous random variable y is uniformly distributed over the interval a to 4a, and we've got to use integration to show that e of y squared equals 7a squared, and then go on to find the variance of y. So, if you haven't done this already and you want to have a go, just give you a moment to pause the video. Okay, welcome back if you had a go. So how do we do something like this? Well, first of all, if we're going to work out e of y squared for a continuous random variable, then e of y squared, we should be familiar with this formula. Normally it's for e of x squared, and it would equal the integral of x squared normally, but we've got to say y squared, times the probability density function f of x integrated with respect to x. But because we're working in y, it's obviously got to be f of y dy. Okay? And our limits go from the lower limit in our distribution, a, to the upper limit, 4a. Now the question is though, what is f of y? What is our probability density function for this uniform distribution? Now I'm going to just draw a quick sketch here to illustrate the distribution, and we'll see if we can work it out. Okay, so we've got y here and we've got our function of y, f of y. And it's going to go from a, let's say a is here, and 4a. It's not drawn to scale, but hopefully it just gives you an idea. And it's a uniform distribution, so we're going to have a line going something like that. Let's just bring it down to here, okay, and it's normally 0 then otherwise, so it's going to look like that. So for f of y, we've got to really work out what the equation of this line is, but we should be familiar with the fact that the area is 1. So this length across here is 3a, so it's got to be 1 over 3a for the height. 1 over 3a multiplied by 3a would give us 1. So we've got f of y. f of y essentially is equal to 1 over 3a when x is in this interval, and it's 0 otherwise. So we can use that, we can pick up on that. So this is the integral now going from a to 4a of y squared multiplied by 1 over 3a. And we're integrating that with respect to y. What I'm going to do is take 1 over 3a out the front of the integral. You don't have to do that, but it's a constant, so it just makes the integral just easier to work with. So we're integrating from a to 4a of y squared then with respect to y. Now we'll put the 1 over 3a there, and if we integrate y squared with respect to y, what we're going to get is y cubed then over 3. In the usual way, just add 1 to the power and divide by the new power, and that's going from a to 4a. So I've just got to substitute our values in. We'll start with 4a, so you've got 4a all cubed over 3, and then you've got minus, and you've got a cubed over 3. And if you work this out, 4a all cubed is going to be 64 a cubed over 3 minus an a cubed over 3. That's going to be 63 a cubed over 3, but we've got times 1 over 3a, so that's going to be over 9a. And I can see that this cancels. You can cancel 63 by 9, that's going to be 7, and you've got a cubed divided by a, that's going to be a squared. So 7a squared then is going to be our answer. Okay, now when it comes to the next part, we've got to find the variance of y. And to do that, we should be familiar with this concept that the variance of any random variable, continuous random variable, is always equal to e of the random variable, in this case y, squared, minus the mean, e of y in other words, all squared. And so we just need to substitute our values in. We've got that e of y squared is 7a squared, and e of y, well, that's going to be the value in the middle here. And to do that, we just simply add our two values together and divide by 2. So that's going to be a plus 4a, which is 5a, divided by 2. And we've got to square that, okay? The mean is essentially 2.5a, 5a over 2. Anyway, if you work that out, 7a squared minus 25a squared over 4 is going to give you 3/4 a squared. Okay, your variance.